7%. It might not sound like the biggest number in the world right off the bat, but when we're talking about global carbon dioxide emissions, it is an absolute mountain. The steel industry alone is responsible for over 7% of all global CO2 emissions. It's literally one of the dirtiest, most energy-intensive industries on the planet. And for decades, cleaning it up just seemed completely economically impossible. But, well, the math is changing, and it's changing fast.
Welcome to this Genecapsule Explainer. Today, we're diving into the future of green steel. More specifically, we're going to break down how a radical new trade policy is acting as the ultimate financial catalyst for a massive industrial transformation. As you'll see, we're going to explore exactly how policies are forcing this massive shift away from traditional coal and towards giga-scale green hydrogen steel.
All right, let's jump right into Section 1, the carbon problem with steel and the threat of carbon leakage.
To really understand the landscape, we have to look at the numbers, and they are pretty staggering. Nearly 92% of the world's steel production right now does not face comparable carbon costs. Meanwhile, just 8.2% of global production, which is mostly sitting in the UK, the EU, Canada, and New Zealand, is subject to a real, meaningful carbon price. We're talking somewhere between 30 to 70 pounds per ton. So think about it. If you're a domestic steelmaker trying to invest in clean, green tech, you're at a massive disadvantage. You're totally vulnerable to being undercut by cheap, dirty imports from that other 92%.
And this creates a very specific economic headache known as carbon leakage. Essentially, it happens when strict environmental policies simply push the emissions across the border. Domestic production gets more expensive, so buyers just import cheaper, high-emission goods instead. The carbon isn't actually reduced at all, it just leaks to another country. Governments quickly realized they needed a really powerful financial stick to protect their own domestic decarbonization efforts.
Which brings us to Section 2, CBAM, the game-changing policy and how it's leveling the playing field at the border.
Enter the Carbon Border Adjustment Mechanism, or CBAM. And guys, the rollout on this is happening incredibly fast. The EU began its transitional reporting phase back in 2023. But as of this year, 2026, the EU's definitive regime is officially live, and they are actively enforcing these rules. And right behind them, the UK is launching its own CBAM in 2027. The core idea is simple. If you want to sell into these massive markets, your goods are now going to face the exact same carbon price as domestic products.
And hey, this isn't just about steel either. Importers of goods in these highly carbon-intensive sectors, we're talking iron and steel, aluminum, cement, fertilizers, electricity, and hydrogen, they all must now purchase and surrender CBAM certificates that actually match the embedded carbon emissions of their imported goods. The era of free riding on carbon emissions to get a cheaper export price, yeah, that is coming to a definitive close.
Let's look at Section 3, the financial impact on trade and the true cost of carbon.
Just to show you how much this is going to hurt the bottom line, based on projections from Global Efficiency Intelligence, by 2030, high-carbon steel imported from countries still relying on traditional blast furnaces, places like India or South Korea, will face EU import charges of between $72 and $83 per ton. But fast forward to 2034, as free allowances are phased out, those penalties absolutely skyrocket to over $210 to $243 per ton of steel. That is a massive economic burden that completely erases the cost advantage of cheap, dirty steel.
To put the sheer scale of this financial stick into perspective, under a medium carbon price scenario, EU CBAM revenue is projected to exceed $4.1 billion annually by 2034. Because of this massive added cost, analysts project a 24% drop in steel imports from current high-emission suppliers. The message is loud and clear. If you want to keep trading in these premium markets, you can't just pay the tax forever. You literally have to change how you make the product.
Which leads perfectly into Section 4, the green hydrogen steel solution, or the technological carrot. So the crucial question is, how do we actually strip the carbon out of this process? For thousands of years, the traditional blast furnace and basic oxygen furnace method, or BF-BOF, has used coal to strip oxygen from iron ore, and that emits massive, devastating amounts of CO2. But the future is H2DRI and EAF. In this new method, we use green hydrogen for the direct reduction of the iron. And here's the magic. Instead of carbon binding with oxygen to make CO2, the hydrogen binds with oxygen to make H2O. You are emitting harmless water vapor instead of greenhouse gases.
Let's break down exactly how this builds into a complete system, drawing on process designs from companies like Midrex. Step 1 requires abundant renewable electricity. Step 2 uses that clean power in a gigascale electrolyzer to split water and create green hydrogen. Step 3 feeds that hydrogen into a direct reduction tower to refine the iron ore into highly metallized, sponge-like green iron. And finally, Step 4 takes that green iron, mixes it with some scrap, and feeds it into an electric arc furnace to create liquid green steel. It is a total, near-zero emission re-engineering of the entire industry.
Okay, moving to Section 5, real-world green steel pioneers and how they are scaling up in northern Sweden.
We are not just talking about theories here. This is happening right now. Take a look at Stegra, a company formerly known as H2 Green Steel. They're building a fully integrated, highly digitized plant up in Boden in northern Sweden, and the scale of this project is just staggering. Backed by 6.5 billion euros in funding, they're constructing an 800-megawatt electrolyzer. That's one of the largest in all of Europe. When this single facility is fully operational, it will reduce global steel emissions by over 7 million tons every single year. For context, that is roughly the equivalent of taking 1.5 million gas-powered cars completely off the road. It's a triumphant, inevitable response to the shifting economic realities that policies like CBAM have created.
And Stegra is definitely not alone in this. Listen to this powerful quote from Martin Pay, the CTO of SSAB, talking about their HYBRIT joint venture. He says, "We want to take this technology to a commercial scale so we can be the first steel company to put fossil-free steel on the market." There is an absolute race happening right now. These pioneers are out there proving that fossil-free steel is commercially viable, and they're pushing the entire global supply chain forward.
Finally, let's wrap up with Section 6, the future of global industry and adapting to the new economic reality.
Now you might be wondering, what if a country outside the EU or UK wants to avoid handing over billions in border taxes? Well, that is where carbon price relief, or CPR, comes into play. Importers can actually reduce their CBAM liability if the goods were already subject to a qualifying carbon pricing scheme back in their country of origin. And honestly, this is the true genius of CBAM. It incentivizes other nations to implement their own domestic carbon taxes. Because think about it, why pay a massive tax to the European or UK government when you could just tax your own industries, keep the revenue in-house, and use it to fund your own transition to green tech? It effectively globalizes the entire decarbonization effort.
Which brings us to the ultimate question for you to take away from this explainer today. We saw earlier that nearly 92% of the world currently operates without comparable carbon pricing. So what happens to the industries in that 92% when these rigid border taxes effectively lock their high-emission steel out of the world's most premium markets? Are we going to see a rapid, unprecedented global investment in green hydrogen technology? Or will we witness a massive fracturing of global trade along carbon intensity lines? The policy stick has been swung, and the industrial transformation has officially begun. Thanks for joining us, and we'll see you in the next explainer.